Okay guys, welcome back. So in the last video I talked about the motion of an object in which the maximum displacement, the maximum vertical displacement of the object is not zero. It moves from the initial position from the ground and it's going to some height h in which it collides with the wall or something like that. So what actually my intention of that video was to understand, to teach you about how the motion of an object changes when the maximum vertical displacement is not zero. So that was about the motion of an object in a horizontal path. Now for the last few lectures I have been teaching you about the projectile of a motion in a horizontal path. So that means the axis is taken as the horizontal. Now if you have not watched those videos, I invite you to watch those videos, the whole series of videos, because the whole series of videos is arranged in a sequential order. It goes from the first point to the second point, so the second point is explained as a derivative of first point. So to understand the second point you need the first point, so to understand the third point you need the first and second point. So there's a sequence. To understand that last lecture you need to understand the lectures from the first lecture to the last lecture. So it's in a sequential order. So if you are not well versed with the subject, I am inviting you to go watch those videos and come back to this lecture. So in this lecture I just change the topic from the horizontal plane to an inclined plane. Now what happens if a projectile happens in an inclined plane? Now in an inclined plane the gravity is acting down, gravity is still acting downwards, whether you are in space or whether you are in a horizontal plane or whether you are in a vertical plane or whether you are in an inclined plane, the gravity is still acting downwards. But the only thing is, in a horizontal way, what you did was you took the gravity only when you are considering the vertical motion of an object, only when you are considering the vertical velocity, only when you are considering the vertical displacement of an object. But if you are setting up a projectile motion, if you are putting some velocity and you are projecting an object in projectile motion, you will also have to consider the gravity, the force of gravity, not the actual force of gravity, the decomposition. You have to decompose the gravity, the composition of gravity in the horizontal direction as well. So I'll take a simple example like this. I'll take a simple example in which right. So this is the horizontal plane. So I will draw an inclined plane in which the inclination is theta. And now I'll take the horizontal direction as this direction upwards. So the horizontal direction will be x positive here, and the vertical direction is that the horizontal direction is along the x-axis upward to the top of the x-axis, from the bottom to the top. That will be positive, so this is x positive, right? X positive, and y positive as perpendicular to the inclined plane and from the y-axis. So this is y positive. Alright, this is x positive and this is y positive. Now this is the inclined plane. So the positive direction of the horizontal axis will be along the inclined plane towards its top, and the positive direction of the vertical plane I will take as the direction in which the direction is perpendicular to the inclined plane and out of the inclined plane, not towards the inclined plane, out of the inclined plane. Alright. Now if I have a velocity like this, if I take an object like this, and if I have some velocity v here, and if I am the angle between the velocity and the inclined plane is alpha, angle between the velocity angle between the velocity and the inclined plane is alpha. The angle between the velocity and horizontal plane is not alpha, it is alpha plus theta. Now don't confuse with that. Don't confuse with that. The angle between the, now I'm taking, I told you the horizontal, I'm taking the horizontal direction positive as the direction along the slope from the bottom to the top of the inclined plane. So the horizontal direction will be in this direction, upwards. Vertical direction will be perpendicular to this direction, I told you. Now the angle, the horizontal direction is along the inclined plane, so I will take the angle between the velocity and the inclined plane as alpha. So the velocity between the angle and the velocity, the angle between the velocity and the inclined plane is alpha, angle between the velocity and the horizontal, actual horizontal, is alpha plus theta. So what it actually we want to find is the alpha value, because no, I am not going to find the alpha value. What is actually needed for this motion is alpha value, because if you have some horizontal motion like this, if I have some horizontal path like this, I took B here and I took alpha here. So the angle between the velocity and the horizontal direction is alpha. So here also angle between the velocity and the horizontal direction is alpha. Horizontal direction is along this inclined plane. Alright, so now you know the angle is alpha. Alright, now where is G? G is acting straight downward. So this is G. I'll take something here. This is G. So what are the compositions of G in the horizontal and the vertical directions? Now I have to decompose G. If this is G, I will draw a line that is perpendicular to this plane at this point and extend here. And if this is theta, this angle is theta. The angle between this between G and the line that is perpendicular to the inclined plane. So this is theta. If that is theta, this should be G cos theta. This should be G cos theta, and this in this direction it should be G sin theta. Should be G sin theta. Now it's very simple. Now it's just like the motion of an object in a horizontal plane. It's very simple. Now you take this object. Now this is as if the velocity of the object is v here, the angle is alpha here. You have some G sin theta acceleration in this direction and G cos theta acceleration that is perpendicular to the motion. So that's all. So this is very simple. If I take the motion of this object, I will take the initial position as A, excuse me, and this position as B, and time t equals 0 at A, time t equals t at B, and it has some projectile motion like this. Alright, so we can put the general equations of motion, linear motion actually. S equals ud plus half at squared. I'll take the maximum displacement as h and the range as r. So AB equals r, right? So I can mark r here because there are too many quantities that I marked, so r will be not visible to you. AB equals r. I'll write it separately. AB equals r. So my intention is to find h and r. H is the maximum displacement, or the maximum height. So the maximum height is not from the ground actually, the maximum height from the inclined plane. Alright. So S equals ud plus, I'm putting from A to B. S equals ud plus half at squared. Now the direction is not, now I'm going to find the value of r first. So in order to find r, I need to find t here. T means the distance from the time taken for the object to move from A to B. From A, and here is B, here is A and here is B, so the time taken by the object to move from A to B. So that's T. So in order to find R, you need the value of T. To find T, now we are put the s equals ut plus half at squared linear equation of motion in a direction so that the maximum, so that the total vertical displacement of this object is 0. So the total, that's the way we did in horizontal, when the object was moving in on a horizontal plane. So in this plane, inclined plane also we are going to do the same thing, but the only thing is now the direction is changed. Now in order to make the total vertical displacement 0, we have to put s equals ut plus half at squared in a direction that is perpendicular to the inclined plane. So the inclination is theta, I will mark it just like this. This is theta and this is perpendicular to the inclined plane. I will mark it like that. Alright. So s equals ut plus half at squared. So the total vertical displacement, or the total displacement perpendicular to the inclined plane is 0. So s is equal to 0. This is equal to ut plus half at squared. So u is actually now not v cos theta, it should be v sin alpha, because it is perpendicular. This is alpha and this is v. So the velocity, when you decompose the velocity, the composition of velocity that is perpendicular to the inclined plane is v sin alpha. So u is equal to v sin alpha. T times t. So now the acceleration is not minus g. Acceleration is not minus g because the only acceleration is the motion of the object is not perpendicular to the horizontal axis. Horizontal axis is horizontal direction. Now this is actually the horizontal direction is this direction. Horizontal direction is this direction. Now it is actually perpendicular to the inclined plane. Now we can say that the acceleration is minus g. We have to find the acceleration in that direction. So if the object is moving perpendicular to the inclined plane, we have found that the acceleration is minus g cos theta. So it's only a we have already decomposed the value of g and then found the composition of g in that direction. So this is minus g cos theta times t squared. So half times minus g cos theta times t squared is equal to minus half g cos theta times t squared. So we can say that half times g cos theta times theta square, t square is equal to v sin alpha times t. So t is not equal to 0. T equals 0 means the initial position. So we have to find, we actually find in the position, actually find in the time, the final position at b. So the velocity is t. So t is not equal to 0. We can divide it by t. So t is actually equal to 2 times v sin alpha by g cos theta. So in the case of horizontal motion, in the case of the way that we presented in the horizontal, the motion of an object in a horizontal plane, only t changes when alpha changes. Now t changes when alpha means alpha is the angle between the velocity of the object, the initial velocity of the object, and the horizontal plane. So in if it is in horizontal motion, if it is the object is projected in a horizontal plane, only the t can be changed when alpha changes, keeping v constant. Now in this method we can also change the inclination of the inclined plane. Now say this inclined plane is not fixed, you have not fixed this inclined plane, you can change. Now we can decrease the value of theta like this, and you can increase the value of theta like this. So, and also you can keep theta constant and change the value of alpha. That means increasing the inclination like this and decreasing the inclination like this. So you can change both alpha and theta. So the value of t depends on both theta and alpha when in an inclined plane. Alright. So t equals 2v sin alpha by g cos theta. So our actual intention is to find r. So r is AB. To find AB, we have to find the displacement in this direction. We have to find the displacement in this direction, which is r. So you know the value of t. So what actually happens is, like in horizontal motion, we can put s equals ut plus half at square, that is parallel to the inclined plane. S equals half ut plus half at square. Now this is parallel. Now I am putting s equals ut plus half it square parallel to the inclined plane. So this is theta, and this is along the inclined plane. So the displacement along the inclined plane is s, that is equal to r. That is what we need to find. So v is not equal to v is equal to actual v cos alpha times t. Right, t is equal to 2v sin alpha divided by g cos theta. 2v sin alpha divided by g cos theta. Now, in the case of the motion of an object in the horizontal direction, the acceleration of the object when we are putting in the horizontal direction was 0. But in this method, in the method of inclined planes, the acceleration of the object when it is parallel or the horizontal, whether parallel to the inclined plane or when we are putting horizontally, the acceleration is not 0 because there is some compression of acceleration minus g sin theta in this direction and minus g sin theta in this direction. Alright, so acceleration is not 0, but the actual acceleration is not plus g sin theta, it is minus g sin theta. G sin theta is along the inclined plane but it is towards the downwards here. It's downwards, but we are only considering the upward motion. Now we are considering this motion from here to here. We are considering this motion. So g sin theta is in the other way, so it is again minus g sin theta. So half times minus g sin theta times t square is equal to minus half times g sin theta times t square. T square is equal to 2v sin alpha by g cos theta holding square. So that's r. We can find r now. You don't have the values of v, alpha, and theta, so you can find the exact value of r. So this is the expression now you can get. So if you need, you can simplify more. This is v square, right? This is v square. 2 times sin alpha times cos alpha is sin 2 alpha. G divided by g cos theta minus 2 squared is 4, you can cancel 1 2 here, so 2 remains here. 1 2 remains here, v squared here. So this is g squared and this is g. This is g squared here, this is g, so g remains in the denominator. 2v squared by g. This is sin theta, this is cos theta squared. So sin theta divided by cos theta is tan theta. So tan theta divided by cos theta. So you can say this is tan theta sec theta times sin squared alpha. Right? So you can take sec theta out from here. Sec theta times you can take v squared sec theta by g out from here. V squared sec theta by g sin 2 alpha minus 2 times tan theta sin squared alpha. So this is the final expression that we get from. So in this video I explained to you about what happens when an object is moved up an inclined plane at some velocity, and that is inclined, which has some inclination to the inclined plane. So we found the value of r. So in the next video we will be talking about finding the value of r when the object is moved down the inclined plane. Now in this video we talked about the object here has velocity, some velocity v here, right? It is moving like this way. Now what happens if the object is moving this way and coming back here? Object is moving on the other direction. If we have some velocity here and it is coming from here to here, so that will be discussed in the next video. So thanks for watching this video, and I will hope to see you back in the next video, and sometimes it will be the last video on projectile motion. So I invite you to watch that video also. So see you then.